Okay, Chapter 7, Quantum Physics. Topic 7.1, Quantum Theory of Light. Okay, so first, what we are going to learn is the initiation of the quantum theory. That means, what is it that starts the quantum theory? Why is it is needed? Why is it that we need quantum theory? What phenomena is it that cannot be explained by classical physics but need to be explained by quantum theory? Okay, so the first thing that we need to like a little bit of revision, okay, is we need to look back at the electromagnetic spectrum. Okay, so we got learn about the electromagnetic spectrum last time in Form 4. Okay, so we learned that electromagnetic spectrum is a continuous spectrum that is consists of 7 types of waves with different frequency and wavelength. So the main thing here is we need to understand that as the wavelength increase, okay, the frequency decrease. Okay, this one here, wavelength increase. You see, from gamma ray, the wavelength is short. Okay, short wavelength. Okay, and then from gamma ray to X-ray, longer wavelength, ultraviolet radiation, longer wavelength, visible light have longer wavelength, and so on. Till radio wave have the longest wavelength. Okay, long wavelength. So as the wavelength go from short to long, the frequency will be in the opposite. Okay, frequency will be from high frequency to low frequency. Okay, high frequency to low frequency. So this relationship between the wavelength and the frequency is something that we learn also in Form 4, which is the wave equation, if you still remember. Okay, the wave equation. So the wave equation is where V, which is the wave speed, equals to F lambda. F is the frequency of the wave, and then the lambda is the wavelength of the wave. So from here, we can see that the relationship between the frequency and the wavelength is that if the frequency increase, then the wavelength will decrease, and the opposite. That means if the frequency decrease, then the wavelength will increase. Okay, so again, this is electromagnetic spectrum. Okay, electromagnetic spectrum. Basically, this part is just a little bit of revision. Okay, a little bit of revision about electromagnetic spectrum, which is it lists out all the different type of electromagnetic wave. Okay, they are all electromagnetic wave. Gamma ray, X-ray, ultraviolet radiation, infrared radiation. Okay, visible light, infrared radiation, microwave, radio wave. They are all electromagnetic radiation. Okay, all of them are electromagnetic radiation. But we group them into different groups based on their application. Okay, based on their application and their characteristic. We group them into radio wave, group them into microwave, infrared radiation, visible light, ultraviolet radiation, X-ray, gamma ray, But although they have different names, but all of them are electromagnetic wave. Okay, all of them are electromagnetic wave. And if you still remember, electromagnetic wave is a transverse wave where, okay, a transverse wave with magnetic and electric component. Okay, with magnetic and electric component. So let's say that okay, this is the direction of propagation. Okay, so let's say this green color is the electric component. Okay, let's say this is the electric component, and this blue color is the magnetic component. Okay, so you can see that okay, this blue is magnetic component, and then this one, the green color, is the electric component. Okay, so that's why it's called the electromagnetic wave lah. Okay, it has the electric component and the magnetic component oscillate at right angle to each other. Okay, the magnetic component and the electric component, they are perpendicular 90 degrees to each other. Okay, so so because they have different wavelength and different frequencies, so we can group them into different group lah. Okay, radio wave, microwave, and so on. Okay, and visible light is the light that we can see lah. Okay, that means from between this frequency, between this wavelength, from 750 nanometer until 400 nanometer. Okay, 400 nanometer. This is the wavelength of electromagnetic wave that we can see with our eyes. That means the cells in our eyes are sensitive to this wavelength of electromagnetic wave. Okay, they are sensitive to this wavelength of electromagnetic wave, so we can see them. Okay, our eyes can detect these electromagnetic wave, but the other one we cannot detect. Infrared cannot detect, microwave, radio wave cannot detect, ultraviolet cannot detect, X-ray, gamma ray cannot detect by our eyes lah. Okay, cannot be detected by our eyes, so we cannot see them lah. We cannot see ultraviolet radiation, we cannot see infrared radiation. Okay, we can only see the wavelength of electromagnetic wave, that is from 400 nanometer until 750 nanometer. Okay. Okay, so this is a little bit revision about electromagnetic wave, and this is the electromagnetic spectrum lah. Okay, electromagnetic spectrum. Alright, so all objects emit electromagnetic radiation. Okay, so why is it that we say all objects? What does it mean? What does it mean by all objects emit electromagnetic radiation? Do our body emit electromagnetic radiation? Is the table emit? Do the table emit electromagnetic radiation? Okay, the paper, the book, your cup, your food, your rice, your fried chicken, do all of them emit electromagnetic radiation? The answer is yes. Actually, all of them, everything can emit electromagnetic radiation. Okay, everything can emit electromagnetic radiation. So why like that? Why is it that anything also can produce electromagnetic radiation? Why like that? Okay, the reason is in order to understand the reason why everything can emit electromagnetic radiation, we have to understand how electromagnetic radiation or electromagnetic wave or radiation is produced. Okay, how is it that how is electromagnetic wave or electromagnetic radiation produced? Okay, so previously we learned that when we have a charged object, okay, let's say we have an electron. Okay, let's say we have electron. The electron is negatively charged. Okay, let's say we have an electron. that is negatively charged. So if we have an object that is negatively charged, then that means around this object you will have electric field. Okay, right now you have electric field. Okay, you have electric field. And what happens when the charged object, let's say the electron, start to move? What happens when the electron start to move? When electron move, you have current. Let's say this is in a wire, okay, in a conductor. So when the electron flow, you will have current. Current will be produced. So remember, current is in the opposite direction as the electron, as the direction of flow of electron. Okay, current, the direction of current is in the opposite direction as the flow of electron. Okay, so when you have electron flow, okay, that means charge flow, then you have electric current. Okay, you have electric current. And we also learned that if we have current, what happens? If we have current around this conductor, you will have magnetic field. Okay, magnetic field will be produced by the electric current or produced by the flowing charge. Okay, produced by the charge that is flowing. Okay, you have magnetic field. And what is the direction of this magnetic field? So you can find out the direction of the magnetic field by using right-hand grid rule. Okay, by using right-hand grid rule. So by using right-hand grid rule, okay, let's say the right-hand grid rule is like this. Okay. So this is the direction of current. The direction of finger is the direction of magnetic field. Okay, direction of finger is direction of magnetic field. So that means that this magnetic field direction is in this direction. Okay, and what happens if the electron change direction, flow in the opposite direction? Then the current will flow in the opposite direction. And what happens when the current flow in opposite direction? The direction of the magnetic field will also change. Right. Okay. Now, what happens if this electron? What happens if this electron oscillate up and down? Okay, going up, going down, up, down, up, down, up, down, oscillate. What will happen? When the electron oscillate going up and down, what will happen is the electric field, okay, the electric field will oscillate also going up and down, the electric field. Okay, the electric field will oscillate up and down. Right. Okay, the electric field will oscillate up and down. This electric field, this line that represent the electric field, okay, it will oscillate up and down. And what happens when the electron oscillate up and down? Remember, when the electron moves, that means you have current. And if the if the electron keep on changing direction, that means the current also keep on changing direction. And if the current keep on changing direction, that means the magnetic field also keep on changing direction. So that means you have magnetic field that also oscillate. And you see the magnetic field, they oscillate in right angle with the magnetic field. The magnetic field oscillate at right angle with the direction of oscillation of the electric field. You see or not? They are perpendicular to each other. Okay, you can see from here also. You see this is the direction of oscillation of the electron. So that means the electric field will oscillate up and down, and the magnetic field oscillate like this, left, right, left, right, left, right. So that means you see they are perpendicular to each other. You see or not? The magnetic field and the electric field, they oscillate at right angle to each other. So that means this oscillation of electric field and magnetic field produce electromagnetic wave. So we have electromagnetic wave. Okay, electromagnetic wave. Okay, so this is how electromagnetic wave is produced. From oscillation of charged particle. Okay, oscillation of charged particle. Okay, now we look at any object. Okay, everything is also made from atom, right now. Okay, everything is made from atom. So that means inside the atom you will have electron, you have proton, right now. Okay, you have electron, you have proton inside the atom. So when the electron have energy, okay, at any temperature, okay, at any temperature except absolute zero, okay, except 0 Kelvin, at any temperature, okay, the particle inside the particle in the object will have kinetic energy. Okay, it will be able to vibrate. So that means whenever when this particle, okay, inside any object vibrate or oscillate, then they will release electromagnetic wave. Okay, they will release electromagnetic wave. So the frequency, okay, the frequency of the electromagnetic wave will depend on how fast do the charged particle oscillate. So if the frequency of oscillation, okay, increase, then the frequency of the electromagnetic wave will also be higher. Okay, frequency of electromagnetic wave or electromagnetic radiation will be high also. Okay, understand? So what is it that can influence the frequency of oscillation? The amount of kinetic energy, right or not? If the kinetic energy is high, then the frequency of oscillation will also be high. So that means the frequency of electromagnetic wave produced also high. Okay, and what is it that can influence the kinetic energy? The temperature of the object. Okay, right now, the temperature of the object. So if the temperature is high, that means the kinetic energy will be high, and the frequency of oscillation will be high, and it can produce electromagnetic wave with higher frequency. So an object that have higher temperature, okay, that means object or high temperature object will produce electromagnetic wave or electromagnetic radiation, electromagnetic radiation of high frequency. So if the temperature of the object is low, the opposite will happen. So low temperature object produce electromagnetic radiation of low frequency. Okay, so same like what is stated here. Okay, so here it says cold object emit wave with low frequency such as radio wave or microwave. Hot object emit wave with higher frequency such as visible light and ultraviolet radiation. Okay, so for example, this object. So you look at the car. Okay, the car have different part of different temperature, right? Okay, different part of different temperature. So the different part of the car will emit electromagnetic radiation of different wavelength or different frequency lah. Okay, different frequency, different wavelength. So for example, the engine of the car and the tire of the car will emit. The temperature is higher, right? So that means here the frequency is higher frequency. Okay, the tire also higher frequency. The body of the car, the frequency is lower lower frequency because the temperature is lower. Okay, get the idea. So, but you look at this diagram and you look at this picture, the engine, which is higher temperature, is red color, and the body of the car that is lower temperature is yellow. Okay, but if you look at the electromagnetic spectrum, okay, if you look at the electromagnetic spectrum, this one, the red color one have lower frequency. Okay, the frequency is lower. That means if the object is lower temperature, then that means it should produce red color. And you see the green color, yellow color have a shorter wavelength. So that means the frequency is higher. So if the frequency is higher, should be the temperature of the object is higher, right? Higher temperature object, the particle will oscillate faster, so will produce electromagnetic wave with higher frequency. Lower temperature will produce electromagnetic wave of lower frequency. So it should be red color have lower temperature, yellow color have higher temperature, green color have even higher temperature, blue is even higher, and purple is even higher temperature, right? But you look at this diagram, you look at this picture, the red is have higher temperature. The yellow and green is lower temperature. You see the building, the house at the back, blue color, even lower temperature. So this picture show the color that is the opposite of the electromagnetic spectrum. Why like that? The reason is the picture in this, the color in this picture do not follow the electromagnetic spectrum. Understand? Okay, the color in this picture, okay, do not follow the electromagnetic spectrum, because this picture is produced by computer, and to make people have a better idea, okay, easier to see which object have higher temperature, which object have lower temperature, the computer purposely color the object with higher temperature with red color, and object with lower temperature with yellow, with green, even lower temperature is blue, and then even very low temperature, then it's black. Okay, so this picture is for the benefit or for the convenience of normal people that don't study physics. Understand? Okay, so that normal people look at the picture can easily identify which part have higher temperature, which part have lower temperature. You get the idea? For example, if you ask anybody in your family that don't study physics one, okay, you ask anybody, you ask them to use color to represent temperature of object. If you let them choose, okay, higher temperature object, high temperature object, hot object, you ask them to use red color or blue color to represent the high temperature, I think 100% they are going to choose the red color to represent high temperature, right? Okay, they are going to choose red color to represent high temperature, because for normal people, okay, for everyday normal people, fire, red color, orange color, fire is high temperature. Okay, ice, blue, or you can say like white color, okay. That means things that are cold, usually the color is darker, like blue color, like that. Understand? So for normal people, easier for them to associate red color for high temperature, blue color for low temperature. Okay, so please do not get confused by the color in this picture. Okay, understand? Please don't get confused by the color in this picture. This color do not follow the frequency of the electromagnetic spectrum. Okay, if the color of the electromagnetic spectrum, red color is the lower temperature. Okay, the yellow color is higher temperature, blue color is the highest temperature, very hot, then blue color. Okay, for electromagnetic the spectrum, okay, the electromagnetic wave spectrum, red is low frequency, blue high frequency. So that means red is low temperature, blue high temperature. Okay, get the idea? Okay, okay, so let's look at another example. Okay, sorry, wait. So you look at this picture, the one with the car. Okay, you look at the picture of this car. So why is it that the computer can detect the different temperature of the object? Because all of these objects emit electromagnetic radiation. So based on the different frequency of the electromagnetic radiation, after detect the electromagnetic radiation, the computer will analyze and will be able to tell which is higher temperature, which is lower temperature. Okay, get the idea? Okay, so this is the same as what we use for the thermometer, right? The infrared thermometer. Okay, the infrared thermometer that okay, we go to shop and so on, we scan our head, right? Okay, our forehead to see what is the temperature of our body. So it works by the thermometer, the infrared thermometer works by detecting the electromagnetic wave that is emitted by our body. So from the frequency of the electromagnetic wave, the thermometer can know what temperature is your body. Okay? Now we look at another example. This one, oven heating element. Okay, you look at this oven heating element. It's very hot, it's so hot until the metal glow red in color. Okay, glow red in color. So here you can see that when the metal is very hot, okay, very hot, the frequency of the electromagnetic wave that is produced is at a higher frequency. That means the frequency is so high that the electromagnetic wave that is produced is within the visible light wavelength. Understand? For example, this car, the electromagnetic wave that is produced by this car, actually we cannot see. We cannot see the electromagnetic wave that is produced by this car because the car temperature, okay, is not high enough to produce electromagnetic wave with frequency that is inside the visible light. So that means the car only produce electromagnetic wave that have frequency in like infrared radiation, microwave, maybe radio wave, or like that. That means within this range. Okay, you have infrared, you have microwave, you have maybe you also have radio wave lah. Okay, but for the heating element, okay, this one heating element, you see it glow red color because the temperature is so high, it's very hot until the frequency is so high that the frequency of the electromagnetic radiation that is produced go inside here, inside this visible light frequency. I mean, okay, you understand? You get the idea? Okay, the frequency of the electromagnetic wave that is produced by the heating element is go into the visible light. Okay, go into the range of the visible light. So we can see that red color, yellow color, orange color. Okay, the light, red light, yellow light, orange light come out. Okay, it's because it's very hot lah. If it is even more hotter, then you will see like this one. You see, this one looks like a bit like white light, right? A bit like white light. Okay. Why it can produce white light? Because it is so hot, much more hotter than the oven heating element. This one, the bulb. The bulb filament is so hot that the electromagnetic radiation that is produced go until maybe until the blue light. Okay, that means blue light also got, green light also got, yellow also got, orange also got, red also got. So all of the light, all of the color also got. Okay, then it will cause the light that is produced. Okay, the electromagnetic wave, the combined electromagnetic wave will look like white color. Okay, we know that if all the color light combine together, then we get white light, right now. Okay, that is the reason why this bulb can produce light that is almost white color. Okay, light that is almost white color because it is so hot, it's very hot until all of the different color also got, okay, all of the color light can come out. So the combined light of different color produce white light. Okay, you get the idea? Okay, so until here we learned that any object can all object also can produce electromagnetic radiation, and if the object have higher temperature, then it will be able to produce electromagnetic radiation that is a higher frequency. Okay, if it is very hot, then and the frequency of the electromagnetic wave go into the visible light range, into the range of visible light, then we can see that the hot object will glow. Okay, glow red color. Okay, like that. So if the temperature is lower, then the frequency of the electromagnetic wave will be lower, and we will not be able to see the electromagnetic wave that is produced because it is not within the range of visible light, so our eye cannot see. But still, every object produce electromagnetic wave. Okay, so that is it for this part, and we will continue again in the next part.